All right. So we are jumping around. This is chapter 9 in the book. I did finally get my hard copy in the mail. It seems pretty reasonable. I think I paid $34 with shipping or something from Amazon, and it was printed like the day I ordered it, which is kind of cool. So they print it on demand. Of course, it would be better if you saw. No, not that. Wait, no. Extend. Better. And better still. Okay. So we're going to be doing chapter 9 in the book, methods. Again, this is not going to be earth-shattering. You can create subroutines that will allow you to do the same task repeatedly just by calling a function. So anybody that needs me to go over what the idea of a function is more than that? Okay, function can take arguments. It can have return values. All right, let's just hop right into it. Quickly get to the meat of what's going on between C# and C. What is method and why are we using methods? I think you guys all understand why methods are important. Calling them. The real trick is how do we pass parameters? Okay, anybody remember pass by address? How many people remember pass by address less than fondly? Yeah, okay, we don't have that here. We have something called pass by reference, which is a little bit easier to handle. But there's still things you need to pay attention to and pitfalls you can fall into. So we'll talk about maybe some best practices. It's a building block. It's a piece of code. It's got a name associated with it. If anybody wants me to go into this in more detail, I will, but otherwise we'll get right to the good stuff. When I say a function or a procedure or a subroutine or a method, they all mean about the same thing. C# specifically calls them methods. That's the lingo. Okay. Okay, so how do we do it in C#? Declaring it, creating it. Everything needs a name. It's how you call it. Usually we want to describe its purpose. In C#, there is a coding convention about how you should capitalize multi-word names. It is not what it shows here, where it says print logo with capital P and a capital L. We use first letter lowercase and then capitalize every word. Different aspects of the C# language will use different naming conventions. Classes always will start with a capital, but for methods we typically do, or methods that are part of a class will do first letter lowercase and then capital for every word after that. If it's a static method, which means that it doesn't belong to a object, it's just sort of there, and I will go into what static means more, you can say capital is the first letter. Okay, otherwise though, there's not a whole lot that's different in terms of creating a method. This is a method that takes no arguments. You must put the parentheses in. You must have a return type, even if the return type is void. Void meaning it's not returning anything. Okay. Okay, great. Static, void. Everybody's heard method body before. A lot of this is, again, this book was targeted at people who have never programmed before. So I trust that you guys have a little bit more knowledge under your belt. The method body, again, just vocabulary that we use to communicate with other engineers. Here's one thing that's a little different. Every method must exist inside something called a class. When you create a project in Visual Studio, it will automatically create a default class for you. Just whatever the name of your project is, that'll be the name of the class. Every method must exist inside of a class. This is not unlike Java. Who's my Java fellow? Yeah, not unlike Java. Everything must be part of a class. So when you create a main function, main is a little bit special still. It still knows that that is where it should start executing code, but it's got to be inside of some class. Okay, calling methods. Nothing too crazy here. How do you call it? You use the name and provide arguments if necessary. Put a semicolon to say that's the end of the statement. Okay? That's it. There's nothing different here. This is what you've done dozens and dozens of times before in 160 or in another course that does programming. This is, again, something that doesn't take any arguments. Any method that does take arguments, it's positional. The first thing that you put in is going to go to the first variable in the argument list. The last thing that you list will go to the last thing in the argument list. It is not like a language like Python where you can provide named arguments. You can't say, oh, my name equals Bob and my value equals 40. You have to say Bob, comma, 40. If you say 40, comma, Bob, it will not work. So anytime you have a method, you can call it from inside another method. Even if you want to do recursion, where you call the same method from inside itself. We are not going to be dealing with recursive concepts in this course. This is a course taken by both electricals and computers. Computer engineers will see this both in algorithms with Professor Shing, I think, and in 161 with Professor Fiandella. So we're not going to use recursion, but it is possible if it's something that you choose to use. Okay. This is going to be the boring demo. The more interesting demos will come later. But let's get those loaded up. So the first class, we talked about getting input and output. Second class, we talked about storing large amounts of data. And now we're talking about creating small building blocks for our functions. The idea is very quickly, we're going to start running our automated tests in a way that gets a lot of data in very quickly, stores it in some reasonable fashion, and then operates on it and produces a result. These are the 3 steps we need. So we need to be able to get data in, we need to be able to process that data, and arrays are a great way of processing large amounts of data. So for actually creating and calling a method, if this ever loads, there we go. So here's our method. Oh, you can't see it. Yeah, I was vamping because it wasn't loading. So. Okay. So here is the simplest way we can do something. In this case, on the outside we have a class. Everything must be inside of a class. This class has what's called 2 static methods. Static just means they don't need an instance of an object to be called. Main is the most important static method. Main will almost always be static. Main doesn't take any arguments. If you auto-generate a project, you will see main taking some arguments. That is going to be, if you called it from the command line, you could pass arguments in. We're not doing that. So here it is. Here we go. Print logo, run. Fan of white. No, you do not. So if the question is, do you have to declare your methods before main? Here I've moved it after main. If I build that, it'll run just fine. Build started. I built all of them, but it doesn't need all of them. So let's just run that again. See, it's fine. So the idea is different from C, where you have to have a prototype above main in order for it to call. Because it's all wrapped in a class, it is able to find all of the methods at once. It doesn't need ordering, which I guess I would consider an advantage. Okay, other questions? Glasses? Glasses, okay. All right, so really nothing new here. This could almost be a C program if not for that console.write line. Get rid of some of these. Nope, actually got to go here, back to my slides. So that's it. In terms of declaring and creating, it's all the same. Getting parameters is a little more interesting, all right? Whether you call them parameters or arguments, you can pass from nothing to as many as you want. I think there might be some hard-coded limit for number of parameters. It's probably up there in like the 1024 to 4096 range. Certainly you're going to get tired of writing before you hit a physical limit on the language. That being said, are you familiar with the idea that a human being can only keep sort of 7 things in their brain at one time?
Yes.
I would have accepted just kind of nodding, but yes, this is great. Anybody else familiar with that? No. Come on, I was really hoping somebody was going to like shout no at the top of their lungs. Nope. Hard no. Never heard of it. The idea is if you are given a collection of objects, you can look at them and just sort of recall what those objects were, up to about 7 objects. If you're asked to immediately keep track of more than 7 objects, your brain just can't really handle more than 7. It's just kind of an empirical limit. So if you are doing arguments to a function or a method, probably keep it concise. Later on, much later on, I'm going to be talking about good quality code practices. And having a zillion arguments coming in is not necessarily a good coding practice. They are assigned by type, so you have to make sure that the types match. C# is a strongly typed language, meaning you need to have a type. You can't have just sort of auto types, although C# does have an auto type. We're not going to use it. Okay, so simple method that takes in a single argument. The argument that it takes in has to be of type int, and it has a name called number. So anytime I use number inside of, there it is, inside of the method, that's going to correspond to whatever I typed. By the way, does this? It doesn't show up on my screen, but it does show up on yours, and it will show up on the video. Not really a complicated use of a function. You give it a number, it prints out either positive, negative, or 0, all based on number. But if you write a method and it works well, then you never have to rewrite that method anywhere else in your program. You can call that method repeatedly, and if you choose to augment that method, rewrite it, change its functionality a little bit, it will trickle down to all the places that you call it. Now, the disadvantage is if you break this function and you call it in a million places, you've broken a million different places, but at least there's only one place you need to fix it. Parameters can be of any type: int, double string, arrays, complex data types, nullable data types, and you can have as many as you like. Something to be aware of, something that some people try to do, down here at the bottom, you have to type and by type, I don't mean physically use the keyboard. You have to give a type to every argument. You can't just say, oh, they're all floats. Every argument needs to have a type, even if they're all the same. You got to say float num1, float num2, float num3. You can't say float num1, comma num2. This doesn't work. Passing in a variable, nothing really to it. One thing I do want to call your attention to that sometimes people forget: you can pass anything that evaluates to a data type as an argument. So to evaluate means you take whatever the mathematical expression is, and whatever its return value is, that can be a type as well. So if I take old quantity times 1.5, that is itself a numeric type, probably a double. Quantity times 2, depending on the type of quantity, could be either an int or a float. If quantity is a float or a double, that has a higher precision. Therefore, it will promote the whole quantity to be a double. So quantity is a double times an integer is still a double. Those rules haven't changed from C. But any arithmetic expression or logical expression, whatever, as long as it evaluates to some data type, you could put it in there. So 2 plus 3 is still very valid. And what would print sign of 2 plus 3 print? Go back to that. If you passed 2 plus 3, positive, because 5 is positive. 2 plus 3 evaluates to 5. 5 is positive. And that just spells out what I just said. They have to be the same type. But you can have promotion. So if you give something as an integer can be promoted to a float, so it'll work. But a float cannot be demoted to an integer. Even if you type 1.00000, it won't automatically become an int. Okay, you have to do something to explicitly cast that float as an integer. Okay, so we've already seen the print sign, we've seen print max, which just compares two numbers and prints out the max of the two. Let's look at those running. Method parameters. Where's my mouse? Okay. So these have a few more. It looks like I've added some. Question? Hurt shoulder. Okay. Printing the sign. Ooh, I may have broken these. I can tell because Bob, my favorite.
We can't see anything.
All right, a few things in here that I may need to undo. Oh yeah, Ouagadougou. Ouagadougou is not the capital of Burkina Faso. Just in case that comes up. The capital. Anybody know the capital of Burkina Faso? Maybe look that up sometime. All right, let's run this. Let's see if this goes. Okay, so we're combining a lot of things in this example. We're creating lists, which we did not finish yesterday, did we? We didn't finish lists on Friday. Ooh. Let's take a hard left, because we did forget, or we didn't have quite enough time. Yes. What was the last thing we talked about arrays?
I think we were talking about multi-dimensional arrays.
Multi-dimensional arrays. All right, so Interstellar is this movie, all right? And he goes into a tesseract. So he's using the time dimension as a dimension he can travel through. That's like 4-dimensional arrays. And if you understood that movie, you're smarter than me. So what was I doing? Arrays. So I didn't actually get to the good arrays. Let's go back in. So we'll have to continue with methods. Where on earth? 264. Arrays. Okay. So I should have started with this. I apologize. I may try to edit this later rather than post it right. Okay, so where we left off on Friday, we had the ability to create arrays. But arrays are contiguous blocks of memory that hold data, and they are fixed size. In other words, you can make them any size you wish, but once you have made them, they cannot change in size. So static arrays like that are really only good when you already know how many elements you're going to need. Now, there are workarounds. You can say, all right, probably I'll never need more than 64, so if I allocate for 100, I'll have a little bit of wiggle room, and hopefully I'll be okay there. Dynamic arrays can grow and shrink to meet the needs of your program. And they're called list, and they have these angle brackets that allow you to specify the type. If this was maybe a junior level course, we would probably have you write your own dynamic array class, and we may, as an exercise, try to start writing one of those. But a list is resized dynamically. You can add elements, remove elements. So whereas a regular array has a fixed size, when you say, my array dot length, you're always going to get the same answer for a given array. Dynamic arrays will not always have the same length. They might have the same capacity many times. But in terms of its functionality, it acts like an array. You can access individual elements. You can modify individual elements. But you get the ability to add and remove items. The difference between a dynamic array and a static array is instead of dot length, you say dot count. Count tells you how many things are actually in the list as opposed to how much memory has been allocated for it. So declaring them completely different from regular arrays. You have a data type called list, angle bracket, int, close angle bracket. That is the type, that whole thing. This is technically a templated class. You could put any variable type in there instead of int, float, string, adventure room, which is a data class we haven't even written yet. Anything that evaluates to a data type can go in there. Creating a instance of that, new, and then parentheses. If you wanted to provide a starting value for the size that you think your array is going to be, so say you do think I'm only going to use 64, but I might need more. You can pass in that initial size into the constructor, and it will pre-allocate 64 elements. But if you asked for the count, it would still say that there are 0 things in there. But it would sort of pre-allocate a block of memory for 64 items. So the difference between a dynamic array and a static array automatically has all 5 elements, in this case 5 elements, pre-allocated. So you can immediately go to those locations. If I use that first line in the top box, said list sub in, and didn't provide any size, okay? If I tried to access element sub 3, it would crash because there is no element sub 3. There's not even an element sub 0. Okay? You have to add items in order for those elements to exist. So by saying add, that is putting it in at the first empty location, in this case sub 0. So if you do that 5 times, you'll have 0, 1, 2, 3, 4, 5. At the end of both of these segments of code, you'll have the same array. But one will be a dynamic list, and one will be a static array. If you did want to create a dynamic array from static arrays, there's a lot involved there. If you create something with 5 elements, you want to add a 6th element. First, you have to reallocate a whole new array with 6 elements. Then you have to copy the first 5 elements out of the original array into the second array, and then finally, you can put a value in the 6th array element, which is what this does. So it says, all right, create this new array of size 6. Then for the first 5 elements, put that existing option into the new option. So you're copying across arrays. And then finally, add in that last element. Or you could just use a dynamic array and say add. And it will take care of that. Now, behind the scenes, what it's really doing is it pre-allocates some amount, and then it starts filling things in. If it ever gets to the end, if it runs out of pre-allocated stuff, it doubles the amount that it's allocated and continues doing it. And it actually does code very similar to this, right? It allocates twice as much size, copies over all the stuff that's already there, and then it continues on. Okay, so let's do this demo, because this is where the cool stuff happens. We were in arrays. Yes, arrays demo. The selected file is a solution. Yes, yes I do. Okay. So yeah, we talked about the for each and iterating over arrays. We wanted to deal with lists. So again, lists can be okay. So lists can be of any type. Strings are nice because they give us something to print out. Here we put 30 in as an argument to that constructor. So what is that 30 all about? It's how many what?
Characters?
No. Has nothing to do with the data type itself. We could have done 30 if it was ints. What it does is it pre-allocates 30 elements. So I don't know what the default is for list. Maybe it's 10, maybe it's 32. But this is saying, hey, I want you to pre-allocate a block that's 30 elements wide. So it'll fill up 30 elements. Once it's filled up those 30 elements, if it needs to, it'll double that size to 60. If it fills up to 60, it'll double that to 120. But that's sort of behind the scenes what's happening here. So then we create an array of strings. This is automatically assigning those 4 names, which I think are right on the cover of the book, so authors. And it's adding them in one at a time. So as you run this, let's drop a breakpoint right there. As you run this, you're going to see that list of strings has a lot of information that you can query about it. So here it is starting, running slower than molasses. If I look at list of strings, here's list of strings. Can you see that it says count equals 0 there?
Yes.
Count equals 0. So I have my original array of strings. It is a static array with 4 elements. String itself is Pedro. That's because we're using an iterator. We're using a for each iterator. Once we run this single line, list of strings now has a count of 1. It does have, let me go over here to immediate, list of strings dot capacity. The capacity is still 30. So that's that pre-allocation. We pre-allocated 30 elements. But as we go through this, each time through, we add another element in, and each time through our count gets larger until we've added all 4. Okay, let's run through this next part. Now, first we used array of strings. That was the static array. We can use for each with the dynamic array. For each doesn't care what kind of an array you've got. It's going to just run through each element inside of that object. So in this case, there's still strings. We can run through them and print them. And if I, where did it go? Control F5. So either way, whether you use for or for each, doesn't matter. The for is only there to show you that you can say dot count. Right, list of strings dot count. And it's accessing it via an indexer, square bracket. Using a for each, you just use the same variable over and over again, and it gets reassigned at the top of the loop. See why for eaches are kind of nice? You don't have to worry about what index you're in. That's really the only reason I exists in the for loop, to let you know which element you're accessing. You're not doing anything with that information. Before we get into moving arrays around, everybody okay with the difference between a static array and a dynamic array? Now there are two kinds of loops. Usually we split loops into two different kinds of loops. One is the for loop. We've used that several times. What's the other kind of loop? A while loop. Now, is there a reason to use a while loop over a for loop or a for loop over a while loop? Yes.
If you don't know how many times the loop will run, if you use a while, we ask for loops to know the number of times it will run.
Textbook. That's a textbook answer. Exactly. If you know how many times or how many items you're going to be operating on, use a for loop. If you have an unknown number of iterations, either you're reading from a file that you don't know how many lines are in, or you're waiting for user input, use a while loop. A dynamic list is much better suited to a while loop. A statically allocated list is better for a for loop. So if you know how many times you're going to run something, or you know how many elements you're going to operate on, well, then you can pre-allocate for that number of elements. Whereas if you don't know how many elements you're going to get, you can use a dynamically allocated array, and you will always be able to add within limits. When would you not be able to add something to a dynamic array? I mean, according to this, you should just be able to say add forever. No, let's assume that like you're giving it good data. It'll still not work forever.
It'll eventually hit a limit to program.
I'm going to need you to be more specific, Alex. Trebek. Jeopardy.
I'm pretty sure there's a number like 2 billion something.
2 billion something. That's an interesting number.
It's only going to print that many number of elements before eventually the system can no longer add any more.
Not quite. Anybody want to help him out? Going to run out of data memory. This laptop, I think, has 8 or 16 gigabytes of memory. And integer is 4 bytes. Now, where you were going with that 2 to the 32, 2 billion, 2 to the 32 is 4 billion, but plus or minus, right? Signed integers. That is the limit on a 32-bit processor. You can only have. This machine is running a 64-bit processor. I imagine if you've bought any machine recently, it's a 64-bit processor, 64-bit version of Windows. But eventually you'll run out of memory. The smaller the machine, the less memory you have. So that's something to keep in mind. And it won't be, if you have, say, an integer is 4 bytes, and you have 4 gig of memory, it won't be 1 million items, 4 gig divided by 4 million. It will be less than that because the operating system takes up some of that memory. The structure around the list, what allows you to actually do the queries on the count and the capacity and things, that's going to take a chunk out of it. So there's going to be some limit. Now, if you're running in an embedded system with 2K of RAM, it's going to run out a lot faster than on my desktop machine. So you really have to target what you're coding depending on if you're working in the cloud or a desktop or an embedded processor. Okay. Here's where people start to break down. See that line, copy array equals array? It's bad. I did it. I did it in the demo. Where? Mouse. Oh, maybe I didn't. Well, let's take okay. Let's take an array int array x equals 1, 2, 3, 4. Int array y. Nothing really interesting going on yet. X is a reference to that array. Okay. If I now say x equals y, scratch that, y equals x, that's an assignment. You would expect that data would transfer from x to y. With me so far? You would be right. There's going to be some data transfer. Okay. Case notwithstanding, that should print out 1, 2, 3, 4. Yes? Write in a notepad. Call me some slack. If I was going to compile it, I'd have done it in Visual Studio. You're absolutely right. But like syntax, yeah, I should have capitalized console and W and L. I'm trying to get a quick point across. And that's what this will print. It will print 1, 2, 3, 4. And if I do the same thing for Y, it will also print 1, 2, 3, 4 because I've obviously transferred the data. Here's where things get a little more interesting. Y sub 2 equals 100. Now I'm going to print out the array Y again. So Y sub 2 is this guy right here. So when I print out the array Y, it's going to say 1, 2, 104. Nothing weird yet. I have not changed X. Not anywhere. In fact, X has only ever been assigned up there. I'll put that semicolon in for you. I'm going to print out X. And you know what I'm going to get? 1, 2, 104. How did X change? Those of you who are squeamish may wish to turn away. This might offend your delicate sensibilities. Well, Professor, no, you said there's no such thing as path address. Technically, there's no such thing as a pointer in C#. There are references, which are quite similar to pointers, but they automatically dereference themselves. Here's what you need to know about pointers or references in C#. Anything that is not a basic data type in float double is a reference type. Everything we've been dealing with that wasn't an int or a float is a reference to an object. It's a pointer. It's just that nothing cares whether it's a pointer. It knows how to deal with it. So list is a pointer. If I go back to my arrays, here they are. That is a reference. And if I were to say string array Bob equals array, this would compile. It would build just fine. But anytime I changed it, I would be changing based on the reference. So array and Bob are references to the same data structure. They're references to that same array. Any changes to one will change the other. It was a rather roundabout way of getting to this method, array.copy. Array.copy does what's called a deep copy. A shallow copy is what we just showed. This just copies the reference. So there's one data, meaning that array, 1, 2, 3, 4. And there are two references that point to that data. That's a shallow copy. It doesn't really do much. A deep copy actually takes each element of the array and moves it. So it creates a brand new array. Sometimes you want that, sometimes you don't. And we'll talk about situations that you might need to care. But you can use the array.copy wherever you want the source, wherever you want to copy it to. It copies it from the first thing to the second thing. So it creates two references and two data. Yeah, you can see that, right? Right.
So we just point at the first reference still, or
The original source one won't be changed at all. It will take a snapshot and move all of that data to a new copy of allocated memory. See if I can quickly. No, I don't have a way to quickly do that. All right.
What's the point of a shallow copy?
Well, it's much faster. That's the first thing. So if you just are moving a few things around, shallow copies are very quick because it's just copying, well, a memory pointer. Technically, it's copying a reference, which has a few more things associated with it, but it's very quick. And it allows you to operate on the same data. So for function passing, you don't need to make a copy of the array. You just need a reference to the array. You don't need to make a whole new array if you're sending it to a function where you're going to operate on that array. So you don't want to copy it in those cases. So for example, let's say instead of doing what I did, writing a bunch of for each statements, what if I had made that a method? Print array. In no particular order, let's just put it up here. Typo. This is int array x. Actually, let's make it something totally different. Z. You know, it's always the later laughs that I think are better because someone has leaned over and explained the joke to you. Okay. So this is a perfectly reasonable use for a method. Write all of the things in Z. So now I could have said print array x. X. Print array y. And then same thing. So it substantially cuts down on the amount of schmutz that I have to sort of parse through. But I don't want to make copies of that array. I don't need a deep copy. All I'm doing is referencing the data inside it. So leave one copy of the data in heap and go through it. Okay? But if I want to copy it and then begin modifying it and have the old copy, I need to use this array.copy. It'll be a deep copy. All right. I think we've actually finished off arrays. So sorry that I forgot to cover the rest of arrays. Lists are super useful. I prefer them in many respects over static arrays. We did not cover multidimensional lists because there's no such thing. Although, if you want to really break your brain, you can create a list of any data type. And we've already said that you can have a list of ints. That is itself a data type. That is a valid data type in C#. You can have a dynamic list of dynamic lists of integers. So you would have to do something like this. X equals new list of ints. And then you would have to say bob.add x. And then you could say bob sub 0, that would be a reference to x, dot add 5. That's how you add one data point to this list of lists. Something to think about. All right. This week we're doing lab. When GitHub actually approves our classroom as an educational classroom, that is when I will send out the invites. But in lab this morning I misspoke. I grabbed everybody's github.com username. That's not how it's going to work. It's going to go to your UMass email, and then you will just link your GitHub username to your email. It'll be that simple. It'll just ask you to choose and select, and you'll link it automatically. And then it will clone your stuff and things like that. If you don't know what I'm talking about with clone, come to lab, and we'll talk about that. Okay, stop the recording.